Section 5.2, Systems of Linear Equations in Three Variables. In the previous section, what we did, we went over system of equations in two variables, say x and y or a and b. But here we're doing three equations. Before we do that, let's look at how do we graph an equation like this: x plus y plus z equals 4. This is one equation that has three variables in it. So how are we going to graph something like this? To do so, watch how we're going to do this. We are not going to do x and y anymore, xy plane. So we're going to do x, y, and z. So it's x, y, and z. You can label them the way you like it. The easiest way to graph something like this is to set two of the variables 0. Say x is 0, y is 0. That gives me z is 4. If you take x 0, z 0, you get y equals 4. If you take y 0 and z 0, you get x 4. So we have 3 points. The first point is 0, 0, 4. The next point is 0, 4, 0. And the last point 0, 0, 4, 0, 0. So for the first one, 0 for x, 0 for y, but z is 4. 1, 2, 3, 4. So that's z. 0, 0, 4, 0. Here. 4, 0, 4. So these are the 3 points that we have. So that's the graph for this kind of equation. Let's look at another graph. Try to graph a different one. Say x plus 2y minus z equals 6. How are we going to graph this? Again, the same procedure. We set x 0, y 0. We get negative z equals 6, and return z is negative 6. So that gives me a point 0, 0, negative 6. If x is 0 and z 0, we get 2y equals 6, so y is 3. So you get 0, 3, 0. If you take y 0, z 0, what do you get? X equals 6. So you get 6, 0, 0. So 3 points are sufficient to graph this equation. Always x, I put always x here, y there, and z there. So the first point is 0, 0, negative 6. Where is negative 6? Negative means down here. That's the negative axis. 1, 2, 3, 4, 5, 6. That's one of the points. The next point was 0, 3, 0. So on the y is 3. 1, 2, and 3. And the last one was 6, 0, 0. 1, 2, 3, 4, 5, 6. The graph would look like this. This is actually, it's not a triangle, as you can see. That's called a plane. So that's called a plane. Another graph. So let's say we need to graph this equation, 2x minus y plus z equals 4. How do we graph an equation like this? So again, set x equals 0, y 0. That will give me z4. So the first point I get 0, 0, 4. Next one, when x is 0, z 0, negative y is 4. So y is negative 4. So that gives me 0, negative 4, 0. What about if y 0, z 0? Then x is 2x is 4. X is 2. So I got 2, 0, 0. 3 points. I'm going to graph these 3 points. Let's see what we do. Same thing. X, y, the origin, z. So we get 0, 0, 4. 1, 2, 3, 4. That's the first point. Next point, 0, negative 4, 0. So for the y, there's a negative 4. 1, 2, 3, 4 here. And the last one, 2, 0, 0. So the plane would go like this. So that's the graph of these equations. Why are we graphing these? Let me show you why. Our goal, the main goal, is to learn how to solve a system of equations in 3 variables. Something like this: x plus y plus z equals 9, x minus y plus 2z equals 1, x plus y minus z equals 5. So what are we actually trying to do here? If you remember in the previous section, we taught you 3 methods. One is called graphing. You solve the equation by graphing, or the system by graphing. And then we told you, like, you graph each one of them. If they intersect at one point, that would be a solution. If they are parallel, no solution. If they are on the top of each other, there's infinite number of solutions. That was from the previous section. Here we have to solve for the 3 variables x, y, and z. So if we need to start with the graphing method, which is way beyond this course, basically you're going to graph each one of them and see these. You're going to get planes like this, similar planes like these. And what happens is you want to see if these planes, they all intersect at one point, or they not all at the same time intersect, or are they all on the top of each other. So that's what that's graphing is for. But we're not going to use the graphing method. We're going to just use substitution and elimination as we did in the previous section. So what we do here is we plan on eliminating one of the variables by pairing the equation. So this means if I look at the x's, if I add them up or something, add 2 equations together, the x doesn't go away. Or maybe you can multiply the middle one by negative. That will eliminate the x's in the first 2, and then eliminate the x in the last 2. What about if I look at the y's? Oh, the y's I think more clear. If I take these together first, see, I'm gonna write that down, and add them up, that will clean up the y's, no more y's. If you can see that, see? Add them up, the y's cancel. So 2x plus 3z equals 10. That will give me an equation that has only x and z in it. And notice the other thing, if I take the last 2 equations together, that will also eliminate the y. You must eliminate the same variable when you pair them out. So here, the y's cancel. I got another equation in x and z, plus z equals 6. So now I have 2 equations in 2 unknowns. Let me rewrite it. 2x plus 3z equals 10. 2x plus z equals 6. Let's say I want to eliminate the x. We multiply by -1. By -1, as we did in the previous section. So this stays the same, equals 10. This is -2x minus z equals -6. And let's see what that gives us. These cancel out. 2z equals 4. So z equals 2. I got z. I got the value of z. So we got z so far. Now I'm going to go back to these 2 equations and pick any one of them. Let's say I'm going to pick the second one. 2x plus z equals 6. 2x plus z is 2. And then subtract 2 on both sides. So x is 2. So we got x and z. Not done. We need the y. To find the y, you can pick any of the 3 equations. I'm going to choose the first one. Always choose the one that has no negatives in it. So x plus y plus z is 9. X was 2. We don't know why. I found z to be 2 as well. Combine, so the y, 2 plus 2, 4, is 9. Subtract 4 on both sides. We get 5. The solution, x was 2, y is 5, and z 2. So this means if I graph these 3 equations on the same plane, the 3 planes will intersect exactly at this point. They're going to all meet at that point. Let's look at another example. How do we solve this system? 3x minus y plus 2z equals 14. X plus y minus z equals 0. 2x minus y plus 3z equals 18. Let's see, does it work the same strategy as before? Yes, look at the y's. The y's look good here because if I take the first 2 together, the y will cancel out, and the last 2 together, the y will cancel out. So if I just write the first 2 equations as they are given, I will get this. And if I write the last two equations together, we get this. So now let's solve them out. If we add, the y's cancel. 4x plus z equals 14. That's one equation. 3x plus 2z equals 18. That's another equation. So what do we get? Keep the 4x plus z equals 14 the same. 3x plus 2z equals 18 the same. It would really be easier if we can simplify, cancel the z's together by multiplying the top one by -2. And let's see what we get. We get -8x minus 2z equals -28. Make sure you multiply each one of them by -2, not just the z. The second equation stays the same. Another thing, notice here when I'm solving equations, although I did not make any changes to the second equation, I still write it as is. So these cancel out. -5x equals -10. Dividing by -5, that gives me the x value. I found the x value, I need to find the y and z. So now I can find the z. Maybe I use 4x plus z equals 14. Substitute the x equals 2 in. This is 8 plus z is 14. Subtract 8 on both sides. Z is 6. Also, let's say I want maybe use the second equation. X plus y minus z is 0. X plus y minus z is 0. You will get the same answers no matter which equation you choose. So x is 2. I don't know what the y is, but z is 6. We get y minus 4 equals 0. So y is 4. So I was able to solve for x, y, and z. 2, 4, and 6. 2, 4, and 6. The next one, let's look at a slightly different kind of example. Let's say they ask us find 3 ordered triples that belong to the following set. Okay, so what is this set? X comma 2x minus 4 comma x minus 9, and I'm gonna put this slash here. This means such that, in mathematics, such that x is a real number. We need to find 3 ordered pairs, 3 of them. Well, different people will get different answers. 3 ordered triples, not pairs, triples. So this means you can pick any, we can pick any value. Value means real value, real number, real value for x. To me, x equals 0 is the easiest. So what does that give me? Substitute in here, that's a 0. Substitute in here, 0 minus 4. Substitute in here, 0 minus 9. So the order triple we are looking for is 0, -4, -9. Now if someone pick up, like, let's say x equals 1 or 2 or -1, that's fine, that's totally fine. You pick x, 5, 6, whatever value you pick, it's fine. So that's why I find the 3 triples belong to this set, because they all the ones you're gonna pick, regardless of what x is, they're gonna all belong to this this set. On a special case, you can be asked to solve a system of equations with 2 equations and 3 variables. Let's say this. So I don't have a third equation, so I can only pair these 2 together. And you see, if you add them up, the z's will cancel each other. And we got this. So what does that mean? We cannot find exactly x, y, and z that satisfies only 2 equations. You need really a third equation. But how do we then present the solutions to such equation? Okay, so the way we do it, if I subtract 3x on both sides, we get y equals negative 3x plus 12. And so what I did, I found y in terms of x. And I'm going to say x, let x equal x. X is just itself. And then what I need, I'm going to take the first equation, given equation, and I'm going to solve for z in terms of x. So I'm going to get everything in terms of x. And you will see in a minute why. So x is just x. Y we solved it was negative 3x plus 12. And z just z equals 9. So x minus 6x plus 24 plus z equals 9. So I distribute the 2 in. Here, if I simplify, that's a negative 5x plus 24 plus z equals 9. And now I'm going to add 5x to both sides because I want to solve for z and subtract 24 on both sides. These cancel, so you get z on the left side, 5x, 9 minus 24. Wait, was that 9 or 4? That was 9. Okay, so that was 9. Minus 15. Yeah, minus 15. So that's the z. I found x, y, and z all in terms of x. So then the way how we're gonna write the solutions down, we say, you know, x, y, z that I wanted is gonna be in this form. X is just x. Y is negative 3x plus 12. And z is 5x minus 15. So that x is a real number. So what does that mean? So I have only two planes. For every x value you substitute in, you're gonna get one triple solution. So this means, like, think about the plane as like a piece of paper like this. That's a plane. And it seems that the other plane, maybe let's say it looks like that. So this is the first equation, and so this is the representation of the first equation. That's for the second equation, given equation. They intersect at a straight line, this line, as you can see, this line. That's the line of intersection. Line of intersection. So what happens is, if you pick a value for x, say 0, you're gonna get 0, 12, negative 15. That's a point somewhere here on the line. If you pick another one, you're gonna get another point, maybe a point here, maybe here, maybe here. There's infinitely many solutions to this. That's what this means, is that there are infinitely many solutions. But to represent the solutions as a set, this is how we represent it. We write it this way. We're looking for x, y, z. We keep x as is. We got the others in terms of x. So all of them should be in terms of one variable. It doesn't have to be always in x. It's up to you. It could be all in terms of y, or all could be in terms of z. That's totally fine. But this means this has infinitely many solutions, this kind of system. The other ones where we got one solution because we had 3 different equations, sometimes you might end up with no solution. If it happens that there's no solutions, this means that 3 planes are parallel to each other. So you have a plane like this, and another plane right below it like that, and a third plane somewhere here. They all parallel to each other. They do not intersect. They're just parallel to each other. So that's when the system has no solution. System has no solution, since they will never meet. We care about the algebraic way, not the graphical method, but the elimination and substitution methods, how we find solutions for 3 equations and 3 unknowns, like this one, 3 equations with 3 variables.